A mountain wave basically is
A wave that kind of moves up and down rather than horizontally.
well, my favorite analogy is looking at a river flowing by. I love to go hiking, so I love to stop and look at rivers. If you think of the different types of rocks that you have in a river, sometimes you have rocks that stick up out and then you have the flow just goes around the rock. There's not much change in the stream. It just kind of flows smoothly by, this laminar flow as we'd call it.
And it can be trapped in a layer in the atmosphere.
And then other times you have the water is really deep and you have the stones underneath and you barely might see a little ripple over that stone. The flow doesn't really speed up.
Or under certain conditions, you can have one large wave that's maybe driving the winds all the way to the surface.
And the third case is if you have a rock just below the surface. So maybe you only have an inch or two of water flowing over the rock, then it will accelerate and sometimes flow really quickly down the rock. And that's the case that we're the most concerned about. The atmosphere can behave like that if it's really stable near the surface. If you have a lot of cold air pulling out of the interior of Alaska over a mountain, it's the same effect where it will just, in a very narrow stream, flow really quickly over, say, Kodiak Island and accelerate.
Winds are flowing over a mountain and forced upward, and the air from those winds is colder than the surrounding atmosphere. It's going to be forced to sink on the other side of the mountain. It's called a buoyancy response. You get an upward response on one side and a downward response on the other because of the sinking. Then that will produce what we call a mountain wave.
Once that wind starts interacting with the terrain, it gets really complex. And there again, if you want to start getting accurate forecasts for Delta Junction or even Fairbanks, you need to resolve the terrain because the terrain will accelerate and decelerate the wind in various ways.
So generally we're all seeing the same problems. In Juneau, they experience similar mountain waves that we do that might impact travel, life, property. And so basically to try to understand this phenomena, we're turning to numerical models. Since we have so few observations, we look to models to try to understand what actually is going on, what kind of flow is happening. Is it going to accelerate, or is this just sort of nothing to be worried about?
And again, this is me, a computer scientist, just starting to learn that when we get the real high resolution and real small scales, it's not just wind channeling through crevices and all, it's turbulence, wind hitting something and then kind of shooting up and coming back. You think of a raging river. The atmosphere is a fluid. You try to visualize water flowing through the mountains. What's going to happen when water starts coming up against this mountain and where the eddy's going to be, because that's where they're going to be in the atmosphere too. It's the same process.
But the problem is that models don't always capture these phenomena. So that's when we start working with Don, because he's exploring the same problems too in high terrain. He's trying to push the model as far as he can, and that involves modeling some of these wind events.
Some of our operational models are fairly coarse. We have one that we use that's 40 kilometers in resolution. In southeast Alaska, we have narrow channels, narrow fjords that are maybe 1.5 kilometers wide. So those are invisible to this model. It doesn't see them. But for large-scale hemispheric circulations over a period of 1 week or a little more, that's adequate. If we want to describe flow around some of these fjords and some of these narrow channels, then we have to scale it and get higher resolution.
Thinking of the rapids is a really good analog, because you know there's a certain structure that goes on there that you can predict. And you could even predict what would happen by all of a sudden just shot some more water in from this angle. But then at the very small scale, where is every drop of water going to go? You get to a point where you just can't do it. It becomes random. It's a very complex world we live in.